Well, thank you for having me today. I got a call from, so I'm Amelie, EcoSynergy. I know a lot of faces here, so it's kind of cool. This is my first Builders and Brews, and I guess I missed out. Should come more. So I got a call from Byron a few months ago and asking me to come and present about my personal house project. It's a case study we're building. So full disclosure, I like insulation. And our dream house is to have a 2-bedroom passive house in the Okanagan type of thing. But what we tried to do with our personal house is to build a case study for the existing market, which is quite a bit more challenging, and keeping in mind cost, disruption, waste, carbon. So we're going to take a whole different approach to our net zero energy pilot. Next slide, please. So why are we doing this? Well, as many of you know, by 2030, give or take 2 years, the National Building Code is going to push net zero energy ready on all new constructions. So we're estimating 2032 for adoption. So what that means for the existing market is that it's a little bit going to be like the EV conversation, where some of them might just become obsolete. Because whether it's operations costs, we're seeing cost of utilities rise every month, every year. So how do we find other solutions to the existing market? So electrifying in Alberta is not easy. Just so you know, I officially have stats that it is the hardest province in the country to do that. So if we can do it here, we can do it anywhere. So the challenges of renovating a current house to net zero energy. Well, depending on where you're living, some of the municipalities allow insulation to setback. So we can add a whole bunch of layers of insulation, and then you drop the loads, and then you electrify. But in my case, I couldn't do that. I couldn't add insulation on the one side of my house. So if I don't insulate everywhere, I create a heat sink, which kind of defeats the entire purpose. So a full passive approach was not something that would have given me the outcome that we needed. Fossil fuel energy in provinces has smaller electrical entrances, and it seems that this was a very revelation to many other provinces where they have 200 amp from the get-go. And in Alberta, because we don't heat and do our hot water with electricity, then we have much smaller electrical entrance. I think I figured out where to put the mic. Not all houses have good solar orientation, whether it's for generation or passive gains. Switching the roof around could be done, switching the sun around, not so much. So how can we capitalize on either one of the two or both of these factors to create passive gains and generation? We love our west, right? We live in Alberta, we have our Rockies, they're west facing. The highest solar gain of the house most times, unless you have a house next to your residence. So a lot of the nice big houses have all their big window panes facing west. So we had a couple projects in Springbanks, and they had these 3-floor walkouts, glass with a staircase. And I had to ask the homeowner, I'm like, are you gonna put a shower at the top? Because it's gonna get really, really hot. So we have some views here that we're always looking forward to, whereas in other countries, they don't have that kind of view, right? They live in a very compact and urban context. Capital upfront costs can be very expensive depending on where you start, where you want to go. And I also felt that we had to address the carbon conversation. So the case study we did is specifically for houses that were built between 1995 and today. The reason why we targeted that market piece is that houses that were built before then could justify larger renovations like plumbing, electrical, finishings, extensions, right? So our house is a 2010 built house, and I didn't feel comfortable shredding my house that is not dead yet to the landfill to meet an energy target. So if we can retrofit our house with the least amount of waste, then I think that is also a winning conversation, a winning combination. So that's why we did what we did the way we did it. Next slide, please. So I just said all that. So, oh, the other thing is disruption, right? So people live in their houses. So during this entire process, my family and I were living in our house. The kids didn't have to relocate. They could just keep their normal schedules going. When we do a full gut reno, it can be very disruptive, sometimes to the break of a marriage. So how do we try to keep all that in check while we go through renovation? Cost effective, and we wanted it to be simple. So something that we could do that didn't require a full construction degree or being a project manager by profession is kind of what we were hoping for. Next slide, please. So we're going to present you, sometimes I just feel that videos just explain better what we're trying to explain. So this is our 3-step process to our net zero energy house, to be verified in part 2, but that's the plan. So first we did aero barrier. We installed this product that air tightened the house without any demolition. And we'll show you the video of how that was done. It's really, really nifty. So we were able to drop the air leakage rate from 4.5 air changes per hour down to 1.2 in about 5 hours. A lot of plastic, you will see. I don't know who's familiar with Dexter, but the house looked like a serial killer was walking in there. Step number 2, we installed the geothermal system. So for the ones that don't know geothermal, geo-exchange is the proper term. Basically, we're just transferring heat from the house to the ground in summer and taking heat from the ground to inside the house in winter, and it just moves the heat around that way. It also provides cooling and hot water needs. And the real kicker is that we did all this, and we kept our 100 amp electrical entrance, and I drive an EV. So these are kind of the highlights where the land developers and protection builders are looking like, how the hell did you do that? You won't know today, but we can tell you more later. And then step number 3, the generation, obviously is kind of the missing piece. We need to be able to generate all the electrical use, so including heating, cooling, hot water, and appliances through a solar array that we had designed and installed on our roof. So 3 steps. All in, this whole process, if we would have had to put it back to back, took about 5 weeks. Next slide, please. So this is quickly a touch base on aero barrier. So we targeted air tightness as usually it is the lowest hanging fruit to drop an energy load. And by doing that, we were able to fit a geofield that could fit in our backyard, really. So we were trying to see how low can we bring the loads without touching the shell of the house. We did not replace windows, we did not add insulation, we did not do anything else to the house other than drop the air leakage rate of the house. So no demo. Oh, sorry. We did take a 4-foot wide piece of drywall in the basement to bring in the geo lines. That's about it. So this is the certificate that aero barrier gives the homeowners or the builders when they're done doing a seal. So what you see on that graph is basically the starting point of the air leakage, the equivalent leakage area, and then the final test. So every time you use aero barrier, they give you this certificate as proof that it actually happened, because sometimes you really don't know where it went. So you don't want to know that you paid for nothing. So they do give you a certificate. And so these were kind of the outcomes. And at the last row where it says air tightness rate, I got busy and I didn't retest my house since then. So I'm estimating we're closer to 1.8 now, because aero barrier was the first thing we did when we moved in. So that was August 2021. The geo came in April. So we lived in the house and we took out some intakes and exhaust, and we capped some stuff, and we did all the holes in the mechanical room, and then the solar array came in with the conduit and everything. So we spray foamed some areas, so I didn't test since then. Okay, I got 10 minutes left. Wow, okay, let's go through the videos. They're finally ready to seal our existing home, because we have energy targets on this home that we're hoping to showcase. The end goal is going to be to make this house carbon neutral. So doing aero barrier is the first step to our project, because we would target the one big thing that could save a whole lot of energy, which is air leakage. And aero barrier is the only technology as of today that can do that in a finished house without any demolition. Aero barrier is an air tightness product that is it's installed with positive pressure. The blower is a big fan, These blowers can go up to about 6,000 CFMs. So by pushing or forcing air into the house, the house is going to want to blow up to the outside. And by doing so, the air in the house will try to escape because it can't stay in, it has to go somewhere. So it leaves residue when the pressure stops. You have to protect all the horizontal surfaces for deposits so that when we turn off the system, then everything falls to the ground. It doesn't damage anything. It could be sticky per my hands. We'll get it all off. So without major renovations or fairly disruptive renovations, AeroBarrier is the easiest way that we know of to bring down the air leakage rate and sustain all substantially. Okay, so we're going to scroll through. So this was AeroBarrier. We have the AeroBarrier installer here, Darren. So if you have questions about the install, what that entails, he's here with us. So you're welcome to reach out to him after. So step 2 was basically installing the geothermal system. And this is basically what my mechanical room looks like now. So everything's electric. We have an electric tank with a heater reservoir, and the big unit on the right, that's the heat pump. It's a little larger than a typical, but it's a little bigger. And so there's a lot of reasons why we went geo, and the biggest one was because we could get away without increasing to a 200 amp. We were able to keep the 100 amp. I did have to change the electrical cable from the meter of the house to the panel board, but we didn't have to dig out anything and change the entrance to the house. So I think we're just going to move on to the other video.
My name is Koen van der Maten. I am the president of Thermal Creek. We are a Calgary-based geothermal heating and cooling design and installation company. When we started our business, most of our clientele was really focused, how do I reduce my gas bill? We're very financially driven. I would say over the years that has changed a lot. A lot of people like Amelie living in existing homes and requesting a smarter way to heat and cool your home. And I understand heating and cooling very, very well, but there's other parts of a house that have nothing to do with heating and cooling that I don't understand as well as EcoSynergy does. And that's why it's great to have an industry partner there who can sort of take my information and then put all the other information together and then have a holistic picture of, well, this is what it's going to take to make this house net zero. So Amelie approached us in Thermal Creek to do a geothermal retrofit for her house. Our company is going to essentially take out the old gas furnace in this house, and we're going to retrofit this house with a geothermal heating and cooling system. Challenge simply with retrofits is that there's not a lot of access. So you need a fairly sizable rig in order to get to that sort of depth. Think of it as I have a big RV and I need to be able to park that in my backyard.
I had city bus.
Yeah. After we've done all of our design work and we've sort of identified where we're going to drill, then it starts with drilling. So that will be the first big step. So drilling, we're going down to depth. Then after we've reached the depth, the actual drill stems get removed and install the geothermal, the prefabricated loops. They're going to go down into the borehole. And once they are down to depth, the boreholes will be grouted. Now grouting is a process. Essentially, this is a thermally enhanced type of bentonite grout that stays a little bit more elastic than, let's say, cement or so. So what it really does is it seals up the borehole well and it makes sure that the loops have perfect contact with the surrounding earth. The next step will be a small header trench to ultimately connect our boreholes in a sort of a manifold type fashion outside, and we run a supply and return line into the house and then ultimately into your mechanical room, and we pressure test everything. And once we know that the pressure test is good and there is no leaks anywhere, then that trench can be backfilled, and really that field will never need any form of addressing. It's very doable.
So this was just a geo piece. If you have more questions, I'm sure you will. We're going to be here a little while. It's kind of unorthodox. And so then once we electrified the house and we were able to get rid of the gas line, which we capped in June, the solar system got installed on the house, and we're hoping that we're going to be net zero energy in a year from now. So stay tuned for October 2023. If you want to switch to the next slide, we can show the quick solar video, and I'll have a couple of do's and don'ts, and that'll be it. This project, the whole house will be running on electricity with a huge solar array on the left and back side of the house. So with any luck, in about a year from now, the whole house will be running on a solar array. You know, we electrified with super efficient mechanical systems that allowed us to cover a roof and get what we're hoping is net zero.
Yeah. I'm David Kelly, CEO and founder at Skyfire Energy. We install solar on residential projects.
How do you feel about the blend of solar and ground loop?
I think it's a great solution. You've basically locked in your energy price for the next 30 years. Obviously, most homes are heating with natural gas, so we don't have the electrical load. Your heating costs are extremely low. And again, you're paying your utility bill up front, putting it on the mortgage, and it's going to be cheaper than paying the utility bill for the next 20 to 30 years. Not knowing necessarily what the price of natural gas is going to be, or the price of electricity is going to be 5 years out, 10 years out, making some reasonable assumptions, it works.
I think that's the key message. It's not so much an ROI anymore. It's a resiliency thing.
Obviously, we've got some different orientations, so it's not a perfect roof.
You have to follow the roof line versus having a straight horizontal array. You can have less footings and have a consistent straight row. You're gonna have to measure twice, drill once. Aesthetics are probably pretty important because you're gonna see the solar for however long you live in the house.
I'm the nerd. I can't wait to have it running, and it's my last piece of my puzzle, right?
Yes.
So there you go. This is a 3-step process in net zero energy in an existing home. Quickly through the lessons learned. So the pros, well, we were able to finance a large part of our project through a mortgage with a renovation loan attached to it. So I didn't have to fork out a whole bunch of money up front. It was quite cost effective. All in, we were looking at $65,000 for the geo, $2,500 for the main entrance and the DCC EV charging. And if I would have went for the insulation approach, I would have looked at $109,000 and an extra 2,000 kilowatt hours on my solar system, which would not have fit on my roof. The exterior insulation would have, isn't it foundation exterior? Yeah. So we were able to do it keeping the 100 amp basically. No demo or disruption. My stepson was living in the basement the entire time. Now he's 14, so he does complain, but that's okay. He wasn't too bothered by it ultimately. The house is now more comfortable in the summer only. I'm not sure it's going to be more comfy in the winter. Stay tuned, we'll find out. It wasn't very long, took about 6 weeks all in, and it was very simple for any homeowner to take that on. The cons, well, the permitting was interesting. If you want to know more about that, let me know. But basically, I got 5 permits that were not needed. And drilling in an urban context had some unknown challenges, such as water geysers, rocks thrown all over my neighbors' yards and their cars. So needless to say, a lot of alcohol was given, and I made some friends. Just like the insulation approach, this cannot be done on every house. You need certain accesses or yard sizes. Like I said, think RV. You need a fair size yard. We are starting to look at front yards in older neighborhoods. So as I said, I'm not expecting the house to be more comfortable. I'm still expecting my windows to condense because I did not change anything to my shell. That being said, I'm finding that currently my house is much drier than last year just because of the power of the blower in the heat pump. And we're not expecting to shave much of the peak load because that's kind of also part of the conversation, peak heating and peak cooling. But I'm wondering if it's going to drop a little bit just because our systems are so efficient right now compared to a natural gas furnace. So again, stay tuned for part 2. We're going to be recording all our findings the next year, and I'll be showcasing this again in October 2023.